I did just start it.
Okay, so I think that worked on my end. Hopefully it worked on everybody else's end. My name is Dan Schultz. I work in Division of Water Rights, and this is the California Environmental Flows Workgroup meeting. So welcome. If we want to go ahead and pull up the agenda again, it always kicks the agenda or the screen share off when the recording starts. Okay, so if we want to scroll down to the agenda items here, we'll just quickly go over the agenda items. So as always, we start with new member introductions and any housekeeping. The new member introductions are anybody that this is your first meeting that you're attending. Following that, we have a presentation by Nate Butler with Stillwater Sciences on the application of the California Environmental Flows Framework to the Los Angeles River. And then Flow West will do a presentation on inoperable flows project, and then we'll get into our round robin updates. So before we get started, was there anything anybody wanted to add to the agenda today? Okay, not seeing or hearing anything, so we can go ahead and get going with new member introductions. So if this is your first meeting you're attending, if you could please raise your hand and I'll call on you and give your name and your organization. Do we have any new members today? Hold on one sec. Let me go to an easier way for me to see this. Who's got their hand up? Let's see. Top on my list is Mark Tompkins, I think.
Hi, everybody. Mark Tompkins from Flow West.
And Shiloh? I think you might still be on mute, Shiloh.
No?
Yes, can hear you now.
Are you all able to hear me?
Yes. Can you hear us?
Hello, everyone. Sorry about that. My name is Shiloh Melendez, and I am the environmental specialist for Hamul Indian Village of California.
Okay, welcome. Rachel Wright?
Hi, can you hear me?
Yes.
Yeah, my name is Rachel. I'm an environmental scientist with the State Water Board in the Division of Water Rights.
And Christian?
Hi, this is Christian Fehrenbacher. I'm an engineer with the Division of Water Rights as well.
Skylar Lewis?
Hi everyone, Skylar Lewis, staff scientist at Flow West.
Emmanuel Rodriguez?
Hey everyone, Emmanuel Rodriguez, data scientist at Flow West.
Patricia Fernandez?
Hi, this is Patricia Fernandez. I'm an engineer with the State Water Board Division of Water Rights Petition Section.
Nate Butler?
Hi, everyone. I'm Nate Butler, environmental engineer and hydrologist with Stillwater Sciences.
Amber Jameson?
Hi there, my name's Amber Jameson, and I'm the Water Advocacy Director with Environmental Protection Information Center, or EPIC.
And Badia Katz.
Hi there, Badia Katz here from Flow West, also a data scientist.
Great. And is there anybody we missed? Great. Well, thank you and welcome aboard, everybody. I just saw my video got turned off when we started the recording as well. It kind of shuts everything down. I don't have any other housekeeping pieces, so I think we can go ahead and jump into our first presentation if you're ready, Nate.
Absolutely. I'll go ahead and start presenting.
All right. Yeah, you can go ahead and grab the share and start presenting.
Cool. Thinking carefully. Okay.
We can see your presentation.
Outstanding. Okay. So thanks for having me, everyone. My name is Nate Butler, Stillwater Sciences, and I'll be talking today about the application of the California Environmental Flows Framework to the Los Angeles River. So first, I wanted to introduce everyone to Los Angeles because I could probably assume everyone's familiar, but I wanted to make sure you're familiar with the river system. It's 51 miles from Canoga Park to Long Beach. There's a lot of different settings it goes through, many of them urban. Back in the day, it was much more of a natural river, of course, and you had a way different look to it than what you might be more familiar with from media and TV like Terminator 2 or Grease. These days, it is more channelized. You see a lot of the flood walls along the side here, but there's still soft bottom reaches. You might be more familiar with the concrete reaches. That's what you tend to see in the media, but this gives you a better sense of like, there are places where they've never paved the bottom because the groundwater level's so high that concrete wouldn't work in those locations. And one of the key things to think about for the LA River is that it is the major ecological, recreational, and flood conveyance waterway. It is many things to many people besides that. Nearly 1 million people live within a 1 mile distance of the river, and more than a third of all Californians live within a 1 hour drive of the LA River. So with so many people so close and so able to be next to it, there are many management goals that exist for the river. This creates an interesting challenge for the CEF process. First things we had to do when we were applying the CEF to the LA River was how do we manage all this information? Because there's so much information here. It's definitely a like fire hose all the time. And so we broke it down into 7 different themes that capture the different management goals. And these were like 7 by looking at the goals out there, understanding the plans that people have put out, and then saying, well, how do we bin these to make it a little bit more manageable? And just because they're in one bin doesn't necessarily mean they don't interact with other bins. There's a lot of interaction between these. And the 7 that we came up with were biodiversity and habitat, tribal cultural, flooding, recreation, urban cooling, water supply, and water quality. We'll get more into the details of these later, but for the first cut we were like, how do we organize this information? And before we dive more into that specifically, we want to ask and discuss a little bit about how did we get here? How do we get to the CEF in the first place? One of the key motivators of this is that multiple actions are ongoing or planned that will likely alter the flows, ecology, and beneficial uses along the LA River. This is constantly happening. There's so many things on the books. The LA River Environmental Flows Project, a separate project that occurred before this, developed an initial toolkit to evaluate the linkage between flows and some of the LA River ecology and beneficial uses. The LA River Environmental Flows Project, though, had a limited scope, and it wasn't necessarily meant to go all the way through SEF. It was focused on looking at the flow criteria for selected focal species and some recreation beneficial uses. And so now we had to go through the SEF and take that extra step to look at all the management goals for the LA River to evaluate the link between flows and how to balance them, getting into that SEF Section C work. So you probably don't need necessarily to be convinced of why to select SEF, but it's important to talk about that it was thought about how SEF was appropriate for the LA River. And the first and one of the key things is that it was funded by the State Water Board, and it was being put forth as the tool to determine flow recommendations in California. In some projects, there are state agencies that are strongly recommending or requiring SEF analysis as part of their decision-making process. And importantly, it was able to build on the previous work by LA River Environmental Flows Project. The LA River Environmental Flows Project was developed concurrently with SEF and essentially was doing part of SEF, especially SEF Section B. But we wanted to take it further all the way to flow recommendations for the entire watershed and looking at other management goals. And importantly, the State Water Board, who's the decision-making authority, has stated they would use the information developed in the SEF process for future decisions. They have their own process that they're doing and they are required to do. But any work that we do with the SEF can be used in that process, and that can help provide information to help them make informed decisions. So the SEF met all the objectives we were looking for, and it made sense to go along that route. And so the next question is, what SEF work has been completed or is in process for sections A and B? So this is largely the overview, which you're all familiar with, but we're adapting it somewhat for the Los Angeles River. There's some unique features of Los Angeles that have required us to adapt the SEF to its needs. SEF Section A is pretty much classic SEF, no real deviation there. We look at biodiversity management goals, except for that's a good point. Instead of calling them ecological management goals, the LA River and people in the LA Basin think about it as biodiversity. So we started shifting some terminology to make sure it was using the terminology in the watershed. And so we were basically using biodiversity instead of ecological. But it's essentially same thing, crosswalk. And then we looked at the natural baseline. I'll talk about Section B and Section C as we get to those discussion points. So let's focus on SEF Section A. First, where are we looking at specifically in the LA River? We broke down the LA River into different locations of interest based on the California Natural Flow database, so we would be compatible with that. You're only seeing the locations along the main stem because that's where we wanted to focus initially, from Long Beach all the way up to Sepulveda Basin. There has been plenty of interest in looking into the tributaries, and the tributaries, as you would know, are part of the flows to the main stem, but we're focusing initially just on the management goals within this reach. Tributaries are being talked about and are something that were brought up in discussions with stakeholders, and we're looking into ways to incorporate them as possible. For the next step, we went and looked in the existing planning documents and sources and came up with the list of biodiversity management goals for the LA River. There were 9 different ones. Some were very broad, like support healthy connected ecosystems from the LA River Master Plan, and some were very specific of Santa Ana sucker recovery. And it was a very specific reach of the river where they felt that Santa Ana sucker recovery was plausible. Next, we got into natural flows. We estimated the natural flows from the California Natural Flow database as required by SEF when you don't have a more specific model. But one caveat that is important to consider and we had to think about carefully was, are the California Natural Flow database able to capture what historical LA River flows are? And the LA River historically was a significantly gaining and losing river. Parts of the river, the Glendale Narrows, which, for those not familiar with the watershed, is right up around here, this reach was significantly gaining. And as a result, some of the California natural flow estimates may not be super representative. And we went back into some historical data from the 1890s that supported this, where they were seeing that the historical flows in the 1890s, after significant modification to the river, were higher than what would be predicted by the California Natural Flow Database. So we have the estimates from the California Natural Flow Database, but take them with a grain of salt. And I would still say, like, in river systems where that surface water groundwater interactions are significant, be cautious. We proceeded on and then asked the question of, how does the channel look now? And would natural flows be able to achieve the ecological functions in the river? And as it surprises no one, I'm sure, channel modifications from flood control and other processes have significantly altered relationships between flow, water depth, water velocity, and shear. Essentially, natural flows will no longer be able to support the ecological functions needed to achieve biodiversity goals, and the CEF Section B analysis is needed. We put out a report with these initial findings in July 2023, and basically sums this up. And we went through, like, the very detailed analysis of looking at all the ecological functions that would be relevant for those goals to basically account for all of this. So then we need to get into CEF Section B. Now, this is where we start to bend and incorporate new things for the LA River again. In the CEF technical guidance, it's all about focusing on the biodiversity goals in CEF Section B. But we wanted to ask ourselves, well, recreation is also a really important goal within the watershed, and we're going to have to look into other management goals in the watershed in CEF Section C. So let's take recreation and try to consider it similarly to biodiversity. Can we do the CEF Section B for recreational management goals as part of CEF Section B to see how well we can take that forward into CEF Section C? I'm not going to talk more about recreational goals and how that was incorporated in this talk. I had to draw bounds somewhere based on time limits, but we were able to do it, and it made sense. And there was ways to basically build everything that would work for biodiversity for recreation. But talking more specifically about what we did for biodiversity, the first thing we did is we looked at the different biodiversity management goals, and we asked ourselves, how do these overlap? Which ones are potentially able to be grouped together? And if we think carefully about what goal outcomes would be, we could come up with a list of essential elements that need to be part of these biodiversity management goals and goal outcomes that would address all these management goals simultaneously. And so we had support healthy connected ecosystems, we had conserve, enhance, and restore habitat biodiversity and floodplain functions, and we had increased habitat connectivity that we said, these are sufficiently similar that we can come up with a list of elements and goal outcomes that would achieve these goals together. And that's one of the ways that we basically had to make the information more manageable. Then we went through and basically asked ourselves, what are the essential elements? And in this case, some of this work had already been done by the LA River Environmental Flows project that SCORP had done previously. And we said, okay, they've identified some. Let's keep building on this. Let's keep going further and trying to see if there's a way that we can expand on their work and incorporate more things that people had talked about wanting to see in that, and people were concerned about in the watershed. One of those things I'll focus on just very briefly is migratory songbirds. People wanted to see that more explicitly considered than it was done in the LA River Environmental Flows project. So we're like, okay, let's talk about focal songbird species and how to basically build a conceptual model for that focal songbird species and get into the details for the flow nexus that they need for their habitat and life cycle. One that I'm going to show for a conceptual model right now, though, is the steelhead migration, because that's one that is very easy to parse, but it gives us a chance to talk about how we took the conceptual model step as the expansive approach to look at all the parameters that would potentially impact the goal outcome. What are all the potential parameters linking the flow and goal outcome that might need to be considered? And then what we actually end up considering will be winnowed down and selected later based upon data limitations and model limitations. So in my mind, it's like taking all the space and all the things so we understand what could have impacted. And then we basically get down to what we can evaluate at this stage, but we're still documenting and keeping track of what is potentially important and might need to be considered in the future. So if we come to a point where we're like, oh, well, we have more information or we want to know more about this specific concern, we have that documented. People can branch out from this set process to look at that. And that's, I would say, a reoccurring theme for our approach to the Ceph and the LA River. Document, show where you're basically setting things aside because of you don't have enough information, and allow people to basically pick that up later. So once you have the conceptual models and the list of parameters, you develop the range of the parameters necessary to support the goal outcome, or what I like to call suitability criteria, what the LA River Environmental Flows Project called flow ecology relationships. And we build those for the different conceptual models. As I mentioned, we utilize the LA River Environmental Flows Project focal species flow ecology relationships when possible. They had developed steelhead for a lot of parameters. We basically expanded on that, giving people a little more look inside what is important. And then we can say, we might not understand everything right now, but we can say, here's the list of potential things. Now, what can we actually evaluate at this time with the available models and data? And so that essentially gets to the flow criteria for those. We're still in the process. Section B is ongoing as we speak. We're still expanding. A focal species will be evaluated in that. So I can't give you those numbers yet, but it's going through that process. And I look forward to when we get to that point. The next thing that we're doing in parallel, because some of this can get started before we actually have flow criteria for the biodiversity and recreational goals, is Ceph Section C. The short summary is we're developing flow recommendations that best align with the many goals across the watershed. That is a very, very brief way of saying a lot of things. There are several steps, tasks that we're going through for this. And I'm going to step through the first two in some detail and then basically zoom through the last three because we would like to know that, but a lot of this is being developed in collaboration with stakeholders. The key things that we wanted to do for the LA River, because there are many people with many vested interests and many strong opinions and thoughts about how things should be done, is we wanted to make sure that we engage stakeholders and get their feedback and make sure they're on board with the process. We want to include them in building the process for a Ceph Section C analysis. So the first thing we wanted to step into was expand engagement with stakeholders and convene a LA River Ceph Technical Working Group, or TWIG. And emphasis is on the working group. We're definitely going to be doing a lot of work in it. We want to determine the structured decision-making process through the TWIG. We don't want to come in and basically say, this is the way it will be done. We want to get their input, understanding, and support on what to do as we make decisions. And we need to determine the functional flow criteria for management goals in collaboration with the TWIG, specifically utilizing their expert knowledge about their different themes. So on June 11th, 2024, we convened the first TWIG. There are a bunch of LA River stakeholders from the City of LA, LA County, City of Glendale, many environmental nonprofits, regulatory agents, tribal representatives, and academics, with multiple representatives from each theme were introduced to the details that we had done up to this point and what the structured decision-making process for CEF would need to be, and initial list that we had compiled from existing documents of what management goals were. Focus of the TWIG 1 was all about creating that collaborative space to brainstorm and ask the questions and refine the CEF Section C analysis. We want to get people familiar with what CEF is doing, because some of them we had talked to beforehand, some of them we've been working with for a while, some of them might have come in fairly green to the process, and we wanted to catch them up and make sure they understood and had a process what the CEF is and what we were asking of them. Multiple action items were developed from the TWIG feedback, and we're currently going through those, including building out more management goals based on what people had said they want to see and their knowledge of the watershed. Now, what is ongoing work is we're going to be collaborating with the TWIG to determine the structured decision-making process. We're going to be reviewing the strengths and weaknesses of various structured decision-making processes out there, identify the key decision points when we will need to be applying it, so people know this is what we need to consider and how we can think about it. Then we'll be going through identifying what we want to use for the LA River CEF, and if needed, adapt it to the LA River CEF needs. We don't want to necessarily take something off the shelf if people don't think it's appropriate. We want to make sure that it is adaptable to what the watershed stakeholders want to see for the LA River. One of the key things about this is we want people to be able to trust the process as an opportunity to work through a lot of complicated, really difficult decisions and find as many opportunities for the win-wins and low-hanging fruit that might not have been overseen before because of the way that people were looking in one area or one discipline. And we want to build that understanding and collaboration across disciplines. Like, a lot of what has been done is basically coming in and talking to as many people as possible and make use of their expertise in the TWIG. Next thing that is also ongoing right now is we're collaborating with the TWIG to develop for each theme a finalized list of management goals. So we'll have a list of management goals for flooding or flood control. We'll have a list of management goals for tribal control. Then once we have that large list, we will be going through, similar to the biodiversity and recreation, and asking, well, what are the groupings that are possible? In some cases, maybe we can't group too much. In other cases, maybe there's opportunities to group. I'll say right now, I've looked at flood control pretty deeply, and there's a lot of things that can be grouped together there. Everyone pretty much says they want they say in some form, flood protection or reduced flood risk. Then we have to go through developing the goal outcomes for management goals with the TWIG. We want the people who are representing these different management goals and themes to articulate what their goal outcomes are. What would be success, measurable success? And then we have to build the conceptual models for each goal outcome. In some cases, we might struggle to find that flow nexus. And there might be areas where we go through and say, this management goal doesn't have a flow nexus, and that's okay. We're focused on the ones that are going to be influenced by changes in flow to the LA River. Once we have the conceptual models, we develop the suitability criteria and unknowns for the parameters. And then we look at the data models available to evaluate the linkages between those parameters and functional flows. And then we go through and use the available data and models to develop the flow criteria as best possible. I will absolutely emphasize uncertainties will exist, but decisions are being made, actions are being taken right now. And the CEF process allows us to use the best available information to understand the system as best we can and move forward to organize how to make decisions into the future. And the CEF process is flexible enough that it allows refinement. If someone comes up and a study comes out that says this is a new thing, we can easily incorporate that into the CEF and add suitability criteria because it will already be set up for this analysis. It's just incorporating and relatively small changes to add additional things to it. The next step after we get through all that is going through an existing and planned flow inventory to understand the flow inputs and outputs along each LOI in the river. One of the challenges of the LA River, and one of the things that we've been struggling with a lot, is in the LA River, existing conditions is outdated. There's so many plans on the books already that we have to basically look into the future and develop a planned flow baseline for analysis. And that is a challenge because some of these plans aren't fully developed yet. So we're going to have to do it with the best available information and some assumptions. This is just an example of all the projects that are occurring on the LA River, with all the ones in blue are in-channel projects. So those are potentially interacting with the flow. It's quite a few out there. And so we're trying to take this into account by looking at existing conditions. That's been largely done by different previous projects, including the LA River Environmental Flows Project. And then we're also looking at how the changes would be occurring along the river to come up with a potential future planned condition hydrology that can be evaluated for the LA River. And I'll fully admit, this is going to be a lot of work and a lot of assumptions and a lot of collaboration with the twig to develop what assumptions we're comfortable with, how to basically come together on this. Once we have those baseline scenarios, then we will be stepping through alternative management scenarios. And I cannot emphasize enough, this will be developed through the twig and probably looked at from a large stakeholder engagement perspective, because we want to make sure people are heard and understood in this process and no one is surprised. We'll be looking at the different ways to achieve the goals, trade-offs that address challenges of optimization, understanding the different management actions that can be taken, flexibility to come up with a preferred flow scenario selection. And again, like I said, going through this pretty fast, we'll develop the flow recommendations from this and the recommended implementation plan towards the end. But these details are still being developed because we want to engage the twig and make sure they're comfortable and feel heard and represented and their needs are being met through this process. So much of this process is meant to be collaborative and working together to make sure people are hearing their voices resonate in this process. We don't want people to feel that they're not being seen here. Out of all this, we're coming up with recommended flows in terms of the 5 functional flow metrics. That's the bare minimum for SEF. But other things that we're intending to come up with is management actions, including recommended channel design measures, potentially to achieve biodiversity and recreational goals at the recommended flows. We're recognizing that there is a lot of interest and there are several projects on the books and moving forward that are redesigning how the channel is going to look in different parts of the LA River. And as such, part of our management actions are going to be what design measures could be done to better achieve management goals in the watershed. In addition to looking at in-channel modifications for management actions, we're going to also be looking at what are the potential recommended watershed out of channel modifications, managed actions to inputs to achieve flow recommendations, and put that all together in how we can move forward to implementation. And that was a lot of information, and I'll be happy to take any questions now.
All right, thank you. Let's see,
So,
looks like Mark has a question.
Yeah, hi Nate. Thanks for the
Hi, Mark.
super interesting. Hey, good to see you, and thanks
Good
for the great
seeing you, man.
presentation. Really, yeah, fascinating to see this kind of stuff happening in the LA River Basin. I know it's probably sort of to be determined in your later tasks like 9, 10, 11, and 12 there, but I wonder if if your group has already been thinking about like on the extreme ends of implementing those flows, so like either the really low dry periods or the really wet high periods, how much ability is there to manage those like flows in those ranges, or will there be lots of new infrastructure that's needed potentially in the future? If you have thoughts on that yet, I know it might not be ready yet, but interested to hear what you think.
Yeah, it's a good question of how much will need new infrastructure versus how much will be um, adapting existing infrastructure. And that is very much an open question. Like we're part of the flows inventory is getting an understanding of where the ins and outs are and where those different linkages could be made between in-channel modifications and where flow comes in, and look upstream to where those flows are and how those could be modified. As of right now, we're trying to be as expansive as possible and think about it from the perspective of what is feasible. That doesn't really get into a lot of detail. I wish I could get into detail more, but we're looking at the different range of water years and asking those questions, definitely asking those questions, because there's a lot of questions there.
Okay, any
Any other
additional
questions?
questions? Yeah, you can raise your hand or drop a question in chat. Okay, not hearing any additional questions. Thank you very much.
Yep, absolutely.
All right, if we want to go back to the agenda. All right, so we can just jump to it here. The next presentation is by Flow West on the Inoperable Flows project. When you guys are ready, you can go ahead and take it away.
Thanks. I'll go ahead and share for our group.
We'll hop back on screen. So you're going to share, Skylar,
Yeah,
from
I'll
your
pull it up.
screen. Great. And this will be a bit of a tag team here between me and Skylar and Emmanuel from Flow West. Great, I see it up there on the screen. I'm going to start and then I'll hand it off for more of the detail information as we go through. And again, thanks to Nate and thanks to the forum for inviting us here today. We're excited to share this work with you. And I think it's a really good kind of, it was a great segue in from the LA River flows work that Nate presented to talk about our work, which has some definite similarities and I think interesting kinds of facing some similar challenges, but probably have some different ones as well. So since I'm new to the forum, I'll just give a little bit bigger background than I gave in the beginning. I'm a geomorphologist and engineer and one of the founders of Flow West, and I've been working on salmon and other habitat restoration, mostly on the West Coast, and really mostly focusing on floodplains in the Central Valley for the past 25 years. And this is some work that really has been part of what we've been interested in for a long time in Central Valley salmon restoration on developing flows, so identifying gaps in the ability to have and use flow data and predict future stream flow scenarios under different alternative future operations that we can use in analyses and management programs for salmonid and other species restoration, although we'll kind of focus on salmonids today. So in this work, we're striving to make two key advances. One is just to have an easier, more user-friendly way to customize and use flow time series across what you'll see is, a very large spatial domain, and be able to generate them for long uh, future alternative time series. And then secondly is to have it at a finer time step. We've mostly been limited to working at like a monthly time step, which, as I'm sure lots of you know already, is very challenging for many of the ecological types of analyses and planning that we want to do. So this work is trying to really get at moving that forward to have a really actionable and user-friendly way to do work at a daily time step when we're doing this kind of analysis. And so we're going to talk about work under really two projects, although they're very related and they kind of flow into one another. The first is a project, sort of what we were thinking of as a pilot project, funded by Metropolitan Water District down in Southern California, although the staff leading it is up in Sacramento. And the second phase, which we're just starting now, is funded by a reclamation, U.S. Bureau of Reclamation Water Smart grant, and still through Metropolitan Water District. They're the grantee, and we'll continue to work with them. So I want to acknowledge, before I dive in and go into more detail and hand it off to the rest of our team here, to Allison Collins at Metropolitan Water District. She's been instrumental in planning and organizing and providing technical input on all of this work. And then, of course, the Reclamation Water Smart program, which is going to fund the second more substantial phase of this work. And then a whole bunch of collaborators. I can't probably really name them all, but a lot of them related to the reorienting to recovery work, led by Trout Unlimited and the state water contractors that we've been working with on questions of habitat and flow and other things needed for restoring salmonids in the Central Valley. So this has sort of flowed out of a lot of different work and lots of really helpful collaborators over the past couple of years. And then last, about Flow West, since again, this is like a new forum really for us. We're a water resources and ecosystem restoration and a data science consulting firm. We're based in Oakland, although we are kind of all located throughout Northern and Southern California and Oregon and a couple other places across the country where we operate remotely. But we specialize in, and you'll hear a lot about today, some of the data management and analytics work we've been doing for aquatic ecosystem conservation, management, restoration. So with that, Skylar, you could probably jump to the next slide. And I'll just give a high level kind of background and summary of what we're trying to address here in terms of a problem. And I knew Nate back when I think Nate was still a graduate student, and I was recently finished with my graduate work, and we shared some data and talked a fair bit back then. I've been working on salmon habitat restoration for almost 20 years, and this work to plan and analyze future ecological conditions, the combination of flow and habitat and temperature, it's always really been hamstrung by a lack of accepted methods or models to develop daily time step flows that people could agree would reasonably reflect operations in the Central Valley. I mean, it is a really complex hydrologic system. There are tons of different rules that operate the flows and diversions and all the kind of conditions that influence flow throughout this very, very large watershed that is the Central Valley flowing into the Delta. And then as we're talking about potential future flows, assumptions around how you might be able to change operations can get kind of contentious at times. So, the established tools, which we'll talk a little bit about today, can be really hard to change, and it can be really cumbersome to get range of different future flows under alternative management scenarios to work with. That's been a real bottleneck and barrier to really looking at habitat restoration under kind of large scale programs to manage the Central Valley. So as I assume probably, although it's a very new group to me, but I assume a lot of you are aware, salmon populations over this past 20 or so years that I've been working on them have become even more stressed. And, we have some really, really sensitive and declining populations of salmonids in the Central Valley. And there's really not a whole lot of time to get better at figuring out a way to understand limiting factors and test out through models and adaptive management the way restoration actions, including flow, but habitat and temperature as well, will work. So we really, really need an improved ability to develop flow and habitat time series under alternative future operations so that we can better plan and more quickly implement and learn from habitat restoration and multi-benefit kinds of projects. Flood management is part of this, agricultural management is part of this. So it's not just flows for salmon, it's a whole suite of objectives that we're typically trying to address. So there are a number of limitations that have been bottlenecks to getting to this point. And among them are that historical flow data is something that we have in a lot of places and we can use. The flows framework that Nate talked about uses a lot of that, and there are pieces of that we've evaluated and used as well. But there are many rivers and upper reaches of rivers, especially in the Central Valley system, that don't have active flow data, active stream flow gauging data. So historical understanding isn't really there and directly in the stream. We do have flow models, but and CalSim and SAC-WAM are probably the two main ones that are in use in the Central Valley, but they can be, like I said earlier, pretty cumbersome to work with. There's a limited pool of users. There's a high demand on the people who do really know the model ins and outs. So basically what ends up happening is, when you want to do something more complicated or kind of outside the normal water resources supply planning modeling, the resources typically just aren't there to get the information we need in a timely manner from those flow models that are available. The available library of flow predictions from those or other models that would represent alternative future operations are pretty limited. They've run lots of scenarios over the years, but they can be hard to get at future or at the past modeling runs. And even when you can, oftentimes they're not really documented in a way that makes us very confident about using them in new processes. And then maybe the main limitation is the monthly time step is preventing us in many cases from representing a life cycle or a limiting factor in the right way that we want to in these evaluations for habitat or population restoration kinds of programs. So our problem statement then, trying to boil it down, is that the current data and tools just aren't sufficient to generate the usable future flow scenarios we need to drive habitat, temperature, other related analyses for aquatic ecosystem restoration projects in California, and we're going to focus on the Central Valley. So with that, I'm going to turn it over to Skylar to walk through really the pilot phase of our project, and then we'll move through to the current work and future work, and then hopefully get some good questions from you all. So Skylar, I'll hand it over to you now.
Thanks, Mark. So with that problem statement in mind, the Interoperable Flows project set as our goal to expand surface water and temperature modeling capabilities to support salmonid restoration planning. So by leveraging existing models and techniques, the project will develop new tools to support flow and temperature scenario development by both improving flow data resolution, both spatial and temporal, and making flow data more accessible and reusable. So we're looking at achieving those goals by first documenting data gaps and limitations of the current flow and temperature data sources, both empirical and modeled. Second, by generating modeled daily time step flow and temperature data sets that can reflect different water operations and management scenarios. And finally, by publishing this data in formats that are both optimized for integrating into salmonid life cycle and scenario planning models, and also are more publicly accessible and intuitive to work with. And our geographical scope is the Sacramento, San Joaquin, and Tulare basins that make up the watershed of the Central Valley, with a particular focus on the present and historical spawning and rearing streams for Chinook salmon and steelhead. So for the pilot phase of the project, our preliminary outcomes so far have been largely published through this Streamflow Explorer R package, which is a work in progress but is available already. We've reviewed several data sources for empirical and modeled flow data and documented these findings through the package and related documentation. And in parallel to that, our team has been working on a flow model pilot project for synthesizing these daily stream flow time series on streams that only currently have monthly model data available. So this model, which Emmanuel is going to talk more about soon, uses a machine learning framework that leverages meteorological data, historical flow operations, and customizable dam and reservoir operation parameters to predict stream flow and create stream flow time series, and with the ability to modify these inputs and create alternative scenarios. So there's some initial case studies developing this method on the Deer Creek and the American River, and this is going to be expanded more in phase 2 of the project. So starting with the data gap documentation and exploratory work we've done through the Streamflow Explorer package. We reviewed California's major data sources for flow analysis and published it through this web page, which is linked here. And the associated R package will continue to be updated with data sets and the modeling outputs as we continue work on this project. For the gap analysis, we've reviewed CDEC and USGS stream gauge networks, as well as the CalSim and SACWAM flow models. I've noted in there we also included in this documentation some linkages to the California Natural Flows database, since it's such a widely used source of modeled flow statistics, but of course not time series data at the level that we're looking for. For the gap analysis, we identified limitations in these existing data sources, so including limitations in geographic coverage as well as in temporal coverage. So the empirical sources, like the specifically USGS and CDEC stream gauge networks, suffer from geographic coverage limitations since some systems entirely lack stream gauges, and even on well-gauged main stems and major tributaries, more minor tributaries of these streams are typically ungauged. And then model data sources, as Mark mentioned, while there's more comprehensive geographic coverage, we have these temporal limitations of the monthly time step that are really challenging for modeling biological flow impacts at the level we need for salmonid restoration needs. Here's just an example of temporal and spatial gap analysis that we were looking at for the CDEC flow gauge network on main stem habitat streams. You can see the temporal coverage on many of these streams beginning in the mid-1980s, but the temporal gaps throughout there. Our Streamflow Explorer package website combines the gap analysis with some guidance for selecting from existing flow data sources based on use case. So what you see here, I'm not going to go through the details, but this covers both ecological modeling use cases at local and regional scales, as well as water resource management use cases. and distinguishes between appropriate uses for empirical flow data and modeled flow data from CalSim and SACWAM, and discusses some of the limitations in each of those existing approaches. And there's a handy also work in progress flowchart providing a step-by-step guide for selecting from these different existing data sources, depending on the type of analysis you're doing and the scale and whether you're interested in actual versus simulated conditions and so on. And then finally, we summarize some different approaches for filling in the data gaps that we've identified. So going through here, number one, we have time series interpolation to fill narrower temporal data gaps in empirical data. Number two, you can use a linear or power series regression to fill gaps in one gauge using data from a different gauge. Number three, you can use existing modeled flow data as is to approximate flows where the existing empirical data is unavailable on a stream system. And number four, working towards downscaling existing modeled flow data from the monthly to the daily time step. So it's that downscaling of modeled scenario flow data to the daily time step that makes up the next component of our project. We've been working on developing methods to create modeled flow time series using as inputs empirical stream gauge data, meteorological data, and reservoir and diversion operations. So to discuss this development work in more detail, I'll hand it off to my colleague Emmanuel.
Thanks, Skylar. And you can just jump over to the next slide. Yeah. So yeah, Skylar mentioned part of the sort of pilot phase of this project, we developed two models for predicting or estimating daily stream flows at Deer Creek and American River. And, you know, the main objective at this point is not to develop production-ready models per se, but rather focus on making sure the data pipeline for supporting the iterative improvement visualizations and publishing of these models, make sure that's in place, working, and it can be expanded to support more than just two use cases. So a bit of background as to the tech stack that we landed on. We developed these two models using NeuroHydro, which is a Python library built atop PyTorch, which is a deep learning framework developed by Google. We're using LSTM, which stands for long short-term memory models, deep learning models. And so these are very common used in time series predictions, and they fit right into the work that we're trying to get done here. In this process, we decided to, the pilot phase, we decided to basically use two cases. On one end, Deer Creek, which is this unregulated stream flow we'd expect the model to perform pretty well on. And on the other end, it's the American River, which is this highly regulated stream flow, which imagines a lot of diversions, and there's a lot of dam operations going into the time series that you get through an observed gauge there at Fair Oaks. Move on to the next slide. Yeah, so without going into too much detail, the NeuroHydro package that we use for these case studies, it's pretty flexible in that it lets you sort of use many different gauges that you want as the empirical data set. So in this case, for American River, which is sort of the case study I'll go over here, we used the gauge at Fair Oaks. It's got a lot of data from 1950 all the way to 2002, and you can split that up any which way you want for the model to sort of use as training, validation, and testing. One of the reasons we also picked the American River was that the NeuroHydro comes packaged in a way with a repository called CAMELS, which itself bundles together a bunch of meteorological data that is used by the deep learning model to make these predictions. It actually does not have any data for the American River. And so we wanted to focus on this in order to sort of create this pipeline, this data pipeline for cases where when we do expand this and there's no data, these locations, we have something we can pull from. So Skylar actually generated a boundary shapefile for us to use for the American River. We used Google Earth Engine, and it pulled data from the ERAS land data set, as well as the Hydro Atlas. And NeuroHydro, which is the library we use for doing this, it has a lot of examples. So we pulled some of the scripts that they have in the documentation and used those to help us generate all the data that was needed to run the model with American River. The end result here, I just added it for discussion, but this serves as a baseline, and we seek to improve this a lot. In deep learning, a 92% correlation. First of all, using correlation to measure time series, to evaluate time series is not necessarily the best, but that's part of this initial pilot phase, is developing metrics that help us identify where the model is performing good, where it's performing okay, and where it needs a lot of improvement. But 92% is fine. For deep learning models, you'd expect the higher, like 97, 99. Some of the initial observations we've found were definitely overestimation of high and middle flows and a bit of a lower underestimation of the low flows. And these are things we'd expect because, as we'll see in the next slide, we don't have any operations data built into this. This is literally the model just linking meteorological data with empirical flow data and using those to estimate stream flow. And if we go to the next slide. Yeah, so the next steps and sort of where I think the real effort will pay off is when we start building in some of these operational constraints into the model. And so our plan is to use the constraints that are built into the calcium Russell files, extract those out, construct a data set with them so that we can just feed that into this deep learning model and fine tune it with these new constraints and be able to apply that to any watershed that we want to expand this to. In addition to this, as I mentioned, we want to focus our evaluation metrics to really hone in on some of the pieces, some of the components. There's some of the parts of the model that are not working very well. So in our case would be emphasizing on peak flows and high flows and be able to make sure that operations data is reflecting what happens in the real world. Also incorporate as much training data as we can into any of these locations. Our use cases for American River, for example, we had to go through Google Earth Engine to generate data sets, but I anticipate they'd probably be not only using that same approach, but additional or manual training data set to be produced. And that's the overview of the model so far.
Thank you. So phase 2 of the interoperable flow project will continue through the awarded Bureau of Reclamation WaterSmart grant, as Mark mentioned. The next steps will include the refinement of the flow modeling methods, as Emmanuel discussed, so adding the operational constraints and the ability to control those operational constraints like dams and diversions to simulate different scenarios and improving predictability. We'll also be looking at tackling temperature data and models in similar approaches as we looked at for flow data. Further developing and refining platforms for data access, building off of what we've done so far on the Streamflow Explorer package. And finally, working to integrate these model results into Salmondo lifecycle and scenario modeling frameworks. Mark, would you like to finish us off?
Take myself off of mute here. Yeah, so just a couple of closing thoughts on some connections and coordination we think we'll likely be doing as we move through this second phase of the work. So there's a range of potential applications that we see immediately, and I'll talk through a couple of them that we've been involved in the past here. So the first one, the most direct connection I think that we see that we've been talking about throughout the presentation, is the integration with salmonid habitat modeling efforts, and providing an interoperable flow input for those efforts. And one place where we've been involved for a long time, almost a decade, I think, at this point, is on the Central Valley Project Improvement Act, the science integration team, which also has been working through a structured decision-making process like Nate described for the LA basin. So there we're going to have a whole variety of potential interconnections as that process, it's very mature process on structured decision making using a life cycle model, moves forward into the future. And then a branch off of the CVPIA life cycle model that's been developed is what I mentioned earlier, the reorienting to recovery. You can see our shorthand for that, R2R. But basically that's added different functionality to the salmon life cycle model that was initially developed under CVPIA to look at hydrology, which CVPIA really only focuses on habitat. So that's why one of the needs for this more resolved flow information came to light. And then in addition to habitat and hydrology, also looking at things like hatchery operations and harvest in the ocean. But having better flow and more resolved flow will likely help that effort in future phases as well. And then also looking at combining our work. We have some work with Trout Unlimited, looking at improving habitat estimates in Central Valley watersheds and combining this data, improved flow data, with improved habitat suitability data to be able to get at existing salmonid habitat for all the different life stages of different runs of salmonids in the Central Valley. And then there's the second bullet here, a number of regional scale kind of decision-making processes around salmonid conservation and restoration. I talked about the CVPIA process already, but there is also work we've been involved in primarily through the Department of Water Resources on the juvenile production estimate for spring run Chinook salmon, which is required under the, I may get this wrong, the incidental take permit, or the biological opinion, I think actually is what it's required under. So tying, better forecasting future flow sort of operations information into that work to get better juvenile production estimates is something we think could be useful as well. And then the voluntary agreements, now called the Healthy Rivers and Landscapes program, which I'm sure some of you are familiar with. It uses habitat and flow information. We've been involved in some of the habitat analyses related to those agreements. And, I think going forward in the sort of adaptive implementation, if that agreement does get finalized and implemented, would be another place where having this ability to develop better interoperable flows for the future operations could be really helpful. There's some other more agricultural linked kinds of conservation practice development that we think this information will be useful for. One of the specific ones we've been working on is fish food production and juvenile rearing of salmonids on rice fields, which, again, to try and plan it at like a large spatial scale throughout primarily the Sacramento Valley would definitely benefit by having a better ability to kind of predict and forecast future flow operations under different hydrologies that could include climate change or different reservoir management scenarios. And then just general kinds of water resources management planning that is regularly going on in the Central Valley system around, urban community kind of water supply and demand, agricultural water supply and demand, and ecosystem water needs. So we think, these kinds of tools, and as they mature, I think they'll get even more effective at helping across these different types of applications. Next slide. I think we have one more slide before going to questions here. Right, some fairly specific integration that we hope to do, and think it is very likely we can do because we've been coordinating already, is another graduate school connection. Ted Grantham, if any of you have heard of Ted's co-equal project, there's a big team, but Ted is the one of the principal investigators on this co-equal project that's going to do some similar work, although the modeling aspect of it will still be, I think, a CalSim set of scenarios. So it's trying to enhance that library of available CalSim, operations modeling scenarios that different planning processes like salmonid restoration planning could use. But they're going to do a lot of work on trying to inform the types of scenarios, the types of conditions, and there's lots of information available on the Co-Equal project. They have a website and everything, but me and one other person at Flow West who's been involved, Aaron Kane, who's been involved in this interoperable flows work, have been asked to sit on like an advisory panel for Co-Equal. So we're going to try really hard to collaborate around the way we integrate operation rules, the types of potential future flow scenarios we're able to simulate with our package of tools, and as much as possible, coordinate with the kinds of background and kind of parameter setting information that the Co-Equal project we think will develop as well. And then I alluded to this earlier. We have this project with Trout Unlimited, funded by the state water contractors, we're calling it HabiStat. So it's kind of using similar statistical approaches to get at habitat conditions in different watersheds, where it's a very similar problem, like we alluded to in the beginning of this presentation around flows, especially in like the less studied systems or the higher reaches of many of the watersheds. We really don't have good physical habitat information, so it's kind of very hard to build in those kinds of conditions into your life cycle modeling or other kinds of ecosystem and habitat management planning processes for salmonids. So we're going to tie the two strains of work here on habitat and flows together to the extent that we can, and be able to ultimately have out there a publicly accessible way to pretty easily get flow to habitat relationships for streams where that kind of data is not been collected historically and is not easy to generate a one-by-one kind of watershed approach. So that's some of the integration we see going forward. And I think with that, we'll thank you all for your time and inviting us here today. And yeah, if you have any questions, we're happy to try and address those here.
All right, any questions? Looks like Eric Stein has a question.
Thanks, Dan, and thanks, Mark and the team. I know we've chatted about this in the past. I had sort of one technical question, one coordination question. I'll start with the technical question. It really has to do with the issue of scalability, right? And how challenging or difficult this is, to scale, right, to larger geographies, and kind of what are some of the key challenges on the scalability part of it. And then my coordination question really is, and I think we've talked about this in the past, is how one of the things that wasn't on your coordination side is, the Nature Conservancy is funding work on a statewide deep learning model for flow prediction at the reach scale for the entire state of California. And I wanted to know sort of how this effort relates or is coordinating with that effort.
Emmanuel or Skylar, do you want to take a crack at the scaling question first?
Sure. So, I mean, the biggest challenge to scaling is always the additional data needed to produce accurate and good predictions at a bigger scale, right? And so we saw at the American River where this library did not have the data needed to support the model and generate estimations. So we'd expect that to come up a lot. The biggest challenge there is not necessarily carrying out the work. At least it wasn't for the American River. It was just writing Python scripts, but computational cost does come into play. At Google Earth Engine took, I think it was 7 hours to generate all the data needed to run the model within the boundaries that we set for the American River. So that's going to be a challenge. But I don't, yeah, should be a challenge, but it's very, very doable.
And then to the TNC deep learning project. So, I mean, we've definitely talked with TNC in the past, more through the Reorienting to Recovery project about their natural flows database. I'm a little embarrassed. I don't directly know about the deep learning project, but I assume it's probably related to that and an outgrowth of that.
Yeah, it's more based on contemporary flows, right? To sort of build on
Yeah.
what they've done for natural flows to get to more contemporary flows.
And I do think they're also connected to the co-equal program. So I think that's probably a good venue for us to, and it just feels like there are a lot of these threads out there, and the co-equal one will probably be a good venue to try and tie a number of them together. So that'd be my initial strategy, would be, to make sure we're connected with them and other work going on to do kind of similar development. But we don't have anything formal going now, but thank you for raising it. Definitely something we'd want to make a stronger connection to.
Okay, well, maybe we can talk more offline on that. So, oh, and I see Bronwyn. Perfect. She's on the line. She can probably answer this question better than I can.
Yeah, I just wanted to jump in. Thank you so much for the presentation. It sounds like really exciting work. And yeah, so I'm with TNC. I'm overseeing the project that we're doing, which is with upstream tech, and is also using long short-term memory, but I think different modeling tools. And like as Eric said, that's like a statewide effort where they are really looking for like statewide data sets, and the approach that you're taking where you're looking at operations in an individual basin is different, and I think could be really interesting to like compare and understand where they're different. Because I know a challenge that they've had so that project is predicting daily natural and sort of existing flows over a 20-year time series. And it should be done, but not fully hosted by the end of this year. But I know that a challenge that project has really had is just we don't have good data sets to represent operations. So there's only so much that the model can learn about these really highly managed systems. So I think that it sounds like it could be really complementary, but I hadn't heard about your project. So I think it's good to hear. Maybe it'd be good to have some more conversations as we move forward with that project. And I was curious with this one, like what's the overall timeline, or like what's the bigger picture on this, and when there might be things we could compare.
And thank you, Bronwyn. I hadn't noticed you were on, so I'm glad you're on. We talked with you right during the Reorienting to Recovery, which is where these ideas took shape. And so the Water Smart grant really just is still getting finalized to go through Metropolitan. So they still have to finalize the grant, and then we haven't really started that phase 2 yet, but we anticipate, I think, September or October, we will start that work. And then it's like a 18 to 24 month project. So over the next year and a half, 2 years, we'll be working on this. And I do think like what you flagged there is really like the most exciting potential, and one I want to get as much overlap and integration with other efforts on, is the digging into the operations models in the Central Valley and the operating rules, and trying to build that into the ability to generate these future time series. That's always been, that's, if we can get something that is generally acceptable to a pretty big group of participants in these processes, I think we would have a really, really helpful tool. And I know that's always been kind of hard to get at in the past. So I'll bet, yeah, we should talk more in the future, because I think the work you've already done could help us, and maybe some of the stuff that we will do could tag on to what you've already done.
Yeah, that sounds great. And then maybe the one other thing I would add, which maybe you're already aware of through co-equal, is we're actually in the process of like finalizing points where we're trying to get daily modeled natural, like unimpaired flow estimates for different climate futures under the co-equal project. So I feel like we're sort of like, we've chosen like the major rim dams and then like some points on the main stem. So I think if there are locations that you already know would be most useful to you and you know them in the next couple of weeks, I feel like we're trying, like we're using this data within that project, and then we're also trying to hope that like having this daily time series of flows under different climate futures could be useful for other folks working on water in the Central Valley. So that's maybe my other plug or potential coordination point.
Cool. Okay, we'll do some thinking about that quickly. I've got a note here. We'll try to follow up with you in the next week or two.
Thanks so much.
Great. Any other questions? Not seeing any. Well, thank you, Flow West team. That was good presentation and good coordination for y'all moving forward. All right, so next on the agenda is our round robin updates. Are there any updates anybody would like to share with the group? Any work you're doing or ongoing efforts? Eric.
Just I just want to make the group, there'll be some upcoming sort of conferences. I think the Ted's name was mentioned. He's coordinating a session at the American Fisheries Society meeting coming up that's going to have a strong environmental flows, component related to fisheries. And so if folks are planning on attending AFS, I just wanted to kind of put that on people's radar screen. So there'll be a whole session on that there. That's coming up in the September, I think.
Great, thank you, Eric. Anyone else? All right, so I think we can go ahead and wrap up. But before we do, are there any potential agenda topics or presentations for our next meeting, which will be on November 12th? If any come to mind between now and then, just go ahead and send me an email and we can get you on the agenda. All right, thank you, everybody.
Thanks, Dan.
Thank you.
Thanks, everyone.
Thanks, everyone.
Thanks.
Thanks, Dan.
Thanks, Dan.